welcome to my channel and welcome to my website. My name is Daryl and this is Programming in Any Language. The website is www.black-duck.com. It's where you'll find all my videos organized in logical order. You can begin with the basics and then move on to advanced concepts. Or you can start with a speed track and build an application from scratch, which should pique your curiosity with the desire to learn more. Looking at the table of contents, we are going to start a new section, Learning C#. We're going to work with data storage, or, as it is often called, file processing. Up to now, no matter how much data we entered into our text boxes, when the power is turned off, everything entered was gone. No more. This section is going to teach us how we can take our data, save it somewhere safe, so we can turn off our machines, go home, have dinner, get some rest, and come back the next day and find our previous day's work waiting for us where we left it. When working with files, there are always three steps. You open the file. This is where you create a connection between the file and the program. You process the file. You will either read from the file or write to the file. Often this requires a loop. Close the file. You disconnect the file from the program. If left open, the file can become corrupted. Here's a flowchart graphically showing the three steps involved. As you can see, the file is opened first. Processing takes place. Depending on the number of records being read or written, this will take the most time. When processing is complete, the file is closed. Typically, you want to keep the action of opening the file and closing the file as close as possible to the actual processing. Keep it tight in there. It's bad practice to open a file long before it is going to be used. Same with closing the file. When you are done with it, close it. There are only two types of files. Text files consist of ASCII or Unicode characters. You can think of text files as an endless supply of text boxes. Your program is simply reading ASCII or Unicode data in no different way than you would handling entries in a text box. If you're reading numbers, the numbers need to be parsed into their numeric equivalent, ints, doubles, whatever. We'll look at that in this section. The second type of file is the binary file. It is nothing more than a series of unreadable ones and zeros. The operating system handles these files. We won't. That is, unless we start working with database engines, things of that nature. In that case, the system handles the conversion for us, and all we see are the results. We will only work with text files. In order to work with files, a file object has to be associated with the file you are going to use. Sounds almost like double talk, doesn't it? .NET Framework provides two classes that are used to create file objects through the System I/O namespace. They are the stream writer, which is used for writing data to a text file, and the stream reader, which is used for reading data from a text file. These two classes are normally not part of your normal development environment, and you need to include them into your program before you can use them. It's pretty simple. Just include using system.io in the directive section of your program, up at the top there. As you can see, the using system.io directive is simply placed near the top of your program. When that is done, you have full access to the stream writer and stream reader classes. Forget to add this, and the system will quickly remind you that something is missing. Easy to fix. Now, a little more information about files. I had mentioned before that text files are a series of ASCII or Unicode characters. Typically, these files can be opened in Notepad. In fact, you can actually create a file in Notepad that could later be read by your program. We often do that. And remember, I mentioned that if you have a text file of number data, prices, test scores, mileage, whatever, those numbers will have to be read into your program as doubles or decimals or integers using the parse method. Binary files, of course, cannot be read as text. If you try to open a binary file, a Word document, an Excel spreadsheet, and so on, you'll end up with a bunch of weird characters that will make no sense. Now, there are a number of ways to access the data in a file. Sequential. This is where you read the first record and it is followed immediately by the next record. And this continues until you have read all the records in the file. Typically, there's an indicator after the last record that lets you know the entire file has been read, some kind of an ending indicator. Of course, there's no rule saying you have to read all the records in the file. You could stop after one or two are read, but typically you do read the entire file. There's also random. This is where the records are read in a file in no particular apparent order. However, when you read the first record, you will find it contains the location of the next record. Read that next record, and it too has the location of the record that follows it. Random files are organized by the operating system or database engine. It handles the reading and the writing. The organization of the records in the file is transparent to you, the programmer. You don't have to worry about it. When writing data to a file, you start by creating the StreamWriter object. This allows you to name a StreamWriter object. From this point on, you refer to the StreamWriter object by its name. We call this one output file. I could just as easily have called it bozo out or my file or some such name. And I can create several StreamWriter objects if I like. That's the reason we give it a unique name. Once the StreamWriter object has been created, opening the file you wish to use with the command file.createText or file.appendText. Which one will be explained in the next screen. Once a file is open, you can use the write or write line method to write your data to the file. Which one? That too will be explained shortly. Finally, you close the file, and this closes the connection. This is sample code. It uses no loop. It simply defines a StreamWriter object as output file. In the next statement, output file is created using the file.createText method, and here it actually names the file we'll be creating on disk, courses.txt. The next two lines write some data to the file. After each line of data is written, a next line character is added. Next, a simple write is used to write the last piece of data to the file. The write command adds no new line character to the data. Finally, the StreamWriter object named output file is safely closed. Now, what's this business with createText and appendText that I was talking about? createText simply creates a new empty file and allows you to add data to it. If that particular file already exists, createText will blow it away and create a new one. So, if a file does exist and it has data in it, kiss it goodbye. createText will blow it away and replace it with new data. Appendtext is not so cruel. Appendtext opens the file that already exists and lets you add data to the end of the file. In other words, your data is safe and this guy simply adds more data to the back end. If the file does not exist, appendtext will create the file as new, just like createText. Which one should you use? That will depend on the application, and that's what we'll be learning with the series of videos found in this section. See you next time. Thanks for watching. We'll get into all this stuff shortly. Don't forget to use the website for easy access to all my videos, and if you get a chance, please subscribe. That way, you'll be notified when something new is available. We'll see you in the next video. Take care.